Hello and welcome to Engineering Simple. So in this video I'll be talking about limits, and this is part 1. And in other parts I will kind of increase the complexity of the limits, like finding the limits. So there are different ways and different methods of evaluating limits. So I'll start in part 1. I'll start with basic limits. That way, just kind of understand the concept, and in other parts the complexity will increase. So in general, we write the limit, of any quantity as a limit of f of x as x approaches a. So that's basically what it reads, which is equal to L. And notice it says approaches and not equals, because if you plot it, so if this is the x-axis, so you might have some value a, so we are trying to find the value of x, or evaluate the limit as x approaches this a, either from this side or from this side, not necessarily equal to a. And we'll see in other videos where when you replace x with a, it will kind of evaluate to 0, and sometimes it's like 1 divided by 0, which is not, obviously does not make sense, but there are ways you can evaluate it, and we'll see in other videos. So really that's what it means when we say approach, as x approaches a. And the examples will help understanding this concept. So the first example is like limit of 1 as x approaches 0. So since this is a constant, it does not change, so it's always 1 basically. So the answer is 1. So that's true for any constant. Now, the limit of x as x approaches 0. So the way you evaluate the limit, basically you just write x, then replace x with the value 0. So 0, which is just 0. If it evaluates nicely to a number, that's the solution. Otherwise, if say like when you evaluate it and it ends like something like 0 divided by 0, then you have to do something. You have to do more work. You have to simplify that quantity before you can plug in the numbers, or something like 1 divided by 0. So you have to do more work, and we'll see in other examples like what that work means. But for now, let's just introduce the concept of limits like easily, and kind of start with basics. So the limit of 2x as x approaches 1. Again, you just write 2x, then replace x with 1. So 2 times 1 is just 2. So it evaluates nicely, so I don't have to do anything. So the limit of x squared as x approaches 1. So again, just write it out. Then just replace x with 1. So that's what I'm going to do here, basically. And 1 squared is just 1. Since it evaluated nicely, I don't have to do anything else. So the limit of x to the power of 4 as x approaches 2. So again, just write out x to the power of 4. Then instead of x, replace it with 2. So obviously 2 to the power of 4 is just 2 times 2 times 2 times 2, basically 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. Since it evaluated nicely, then I don't have to do anything else. Now, let's evaluate the limit of 2 times x squared plus 4 as x approaches 2. Again, I'm just going to write out this quantity. Then the first step is just replace x with 2 and see if it evaluates nicely. So 2 times 2 to the squared is just 2 times 4 plus 4. 2 times 4 is 8 plus 4 is 12. So evaluated nicely, so I don't have to do anything else. Now let's evaluate the limit of 3 times x squared minus 2 as x approaches 1. First step is I'm just going to write it out. Minus 3 times x squared minus 2. Then just replace x with 1. Then just simplify, basically simple algebra. 3 times 1 squared is just 1 minus 2. 3 times 1 is just 3 minus 2. 3 minus 2 is just 1. So we got a nice number, so I don't have to do anything else. So now let's evaluate the limit of minus 3 times x squared minus 2 as x approaches negative 1. So again, the first step is just write it out, negative 3x squared minus 2. Then just replace x with negative 1. So negative 3 times negative 1 squared is just 1. Negative 2. Negative 3 times 1 is just negative 3. Negative 3 or minus 3 minus 2 is just minus 5. Since I got a nice number, then I don't have to do anything else. So now let's evaluate the limit of minus 3 times x cubed minus 2 as x approaches negative 1. So like always, just write out the quantity, minus 3 times x cubed minus 2. Then the second step, just replace x with the value. So in this case, negative 1 plus 2. So minus 3 times minus 1 cubed is just minus 1. Minus 2. So minus 3 times minus 1 is just plus 3. And I'll drop the plus sign. Minus 2. So 3 minus 2 is just 1. So again, I got a nice number, so I don't have to do anything else. And just notice here, so I just write out the quantity instead of each time writing the limit, limit of x approaching negative 1, then the quantity. But keep in mind you're dealing with the limit. So the same thing here. Just write out the quantity x cubed minus 2 times x plus 1. Again, now I'm just going to replace x with 1 minus 2 times 1 plus 1. 1 cubed is just 1 minus 2 times 1 is just minus 2 plus 1. 1 minus 2 is minus 1 plus 1 is 0. So the same thing here, just write out the quantity, then replace x with the value of 2. 2 cubed is 8 minus 2 plus 3. So 8 minus 2 is 6 plus 3 is 9. So again, these are nice. You just kind of plug in the numbers and you solve, or you basically simplify using simple or basic algebra. But in other cases, the limits will not evaluate to a nice number. Then you have to do more work, in that will be in the other videos. So that was it for this video. If you want to watch more videos, you can go to Engineering Simple. Thank you and have a great day.